So today I am breaking down Diffusion Mamba, also known as DiMSUM, a new architecture that pushes image generation to a whole new level. It fixes some of the biggest weakness in both transformers and Mamba based diffusion models. And not only fixes, it does it much smarter. Transformers produce great results, but their quadratic loss slows everything down. Whereas Mamba a state space model is faster and handles long sequences really well. But it has also one big flaw. It relies on a scanning order when reading image patches. If the scanning order is wrong, the model loses important spatial relationship, especially global structure. So earlier Mamba based diffusion models never reached their full potential. Here is the full architecture of DIMSUM shown in figure 1. As you can see in the image, it is similar to Vision Mamba where we take the which where like these patches and embedding things are all similar to Vision Transformer, where we map the 2D image into a sequence of tokens. The core engine here is the DIMSUM block, which contains a DIM block, a transformer block, and these are repeated to form a network, deep network. In Inside the dim block, you can see special Mamba. Here the tokens are interpreted back in 2D and Mamba scans them in a structured way using sweep 4. You can see check the section below here. Um yes, here. Here you can see sweeping is done in multiple direction, left to right, right to left, top to bottom, bottom to top. All these are done to capture spatial structures like shapes, objects, boundaries, and layout. Then there is wavelet Mamba. This was the sweep, and this is a wavelet Mamba. It's also given below. Yes, here. So in wavelet Mamba, the same input is passed to a wavelet transform. This breaks the feature into multiple frequency bands. These multiple frequency bands are flattened into sequences. Mamba scans them using window-based scanning inspired by CNN kernels, and the pipeline finishes with inverse DWT to rebuild the feature map. After that, the final layer is cross-attention fusion layer. So with the sweep scan Mamba, we got the spatial features, and with window scan Mamba, we got the frequency features. So now the cross attention fusion layer is used for fusing both of them. These outputs are concatenated and linearly projected. This forces deep interaction between the local spatial information and the global frequency patterns, which is the novelty of this dim sum architecture. You can see in spatial frequency Mamba block there is conditioning. This is added just before the Mamba layers. So instead of initializing the hidden state with 0, which are done likely in normal Mamba, here DIMSUM sets the initial hidden state equal to learned tokens, or we can say class embedding, which give Mamba a global hint about what type of image to generate. You can see the transformer weights are shared across all levels. These are globally shared weights which are added after dim block. What they actually do is they help the model to understand large scale relationships. It is, you can say it as global mixing layers. Then these layer normalization and things are there in which RMS normalization, gated MLPs and other things are there in these blocks, which improves the stability, expressiveness and training speed. After flowing through all DIMSUM blocks, the final token sequence is linearly projected and reshaped back to 2D, sent to diffusion output head to predict the velocity. What velocity here is the flow matching. Flow matching. This was all about the diffusion Mamba. Now let's go on the result. So, what DIMSUM actually achieves in practice? Yes, in the experiment section, you can see DIMSUM was tested on major image generation benchmarks like ImageNet, Celib AHQ, and Elson Church, and the results were very impressive. It consistently delivered lower FID scores, meaning that the generated images are closer to real images. It achieves higher recall. It converges faster during training. Like mm, you can see the tables. Yeah, see the everything about training is given in this table. Most importantly, you can see the dim sum outperforms DIT and DIFSUM. DIFSUM and DIT are the strongest and most used transformer based and the SSM based models. In conclusion, DIMSUM combines spatial scanning, frequency scanning, and global transformers inside each block, letting the model capture fine details, global structures, and long range dependencies all at once. Thank you.